before we talk about Galileo and another philosopher that I know you appreciate and that I'm extremely curious about, let me ask you a quick question. What is Project Lyra?
Well, so there is a project to come close to an object that flies near Earth that may have originated from outside the solar system. And I should say we also, within the Galileo Project that I established last year, we are designing a mission that will do just that. And it has two components. First, you have to find an object of interest. Okay, and it's just like a dating app. You look most of the time you swipe to the left, but
I've never tried it. I don't know.
I didn't either, but I know that that's the practice. But in this case, the date costs $1 billion. Okay, so you have to be really careful as to which object you're dating. And by dating, I mean coming within 1,000 kilometers, so you can take a close-up photograph or maybe land on it. Right. We already did that with an asteroid called Bennu with the OSIRIS-REx mission, and it will bring back some material from the surface of that rock to Earth next year. But if you think about the possibilities, they're quite intriguing because, maybe it will not be a rock. Okay, maybe it will behave in ways that deviate from the way comets or asteroids behave. And then if we land on it, we might see bolts and screws, and we might see a button that we can press. And frankly, that would be my biggest thrill. Before I die, I want to press a button manufactured by another civilization.
Well, this is how you came to, I'd say, prominence in the public sphere rather than because you were already doing wonderful things as we've already understood. In 2017, there was something discovered called that was named Oumuamua.
Oumuamua.
Yeah. Sorry. There's a reason why I say Oumuamua because it reminds me of a song that was sung by a woman named Teresa Desio, I believe her name was, in the 70s. I was a little kid, and this thing played all over Italian radio, and it was called Aum, A-U-M, A-U-M. And it's a Neapolitan saying, more or less, that says, more or less, hey, this is between us. So I keep hearing Aum.
In this case, it's not between us, it's between us and whoever produced that thing.
Yes.
And what I should say is, so the reason it's called Oumuamua is because it means a scout or a messenger from afar in the Hawaiian language, and the telescope that discovered it was placed on Mountain Haleakala in Maui. I actually visited that place a few months before the detection took place, and it's a beautiful site. They have also a telescope looking at the sun. And the funny thing is, astronomers always complain that the telescope is not big enough. They were complaining that the telescope looking at the sun is not powerful enough. Even though it's the biggest telescope looking at the sun ever built, they don't get enough light because they basically try to learn about details on the surface of the sun, and they would prefer to have even more light. And it just shows you that scientists in principle are never satisfied. We can always get more data. But at any event,
nothing wrong with that.
Not in my book.
Yeah.
In other people's book, there is. The telescope there, Pan-STARRS, surveys the sky, and it was established after the U.S. Congress tasked NASA to find 90% of all objects bigger than a football field that may hit the Earth because they pose a danger. We learned from the lesson of the dinosaurs. We don't want it to happen to us. The dinosaurs were not smart enough to develop telescopes. We can do it. So we survey the sky for rocks that may hit the Earth and cause damage to a big city. Now, Pan-STARRS was established for that purpose. And guess what? In 2017, on October 19th, it discovered an object that came from outside the solar system. How did we know that? Because it moved too fast to be bound to the sun. And that was declared as the first interstellar object. And I was interested because a decade earlier, I predicted in a scientific paper that Pan-STARRS will find nothing. Okay, based on the number of rocks we know exist in the solar system, assuming that all stars are like the sun, you just don't expect enough rocks flying between stars. Okay,
right.
And that was a surprise to me. And then, of course,
you were wrong, and you were okay with that.
Of course, that's the way you learn, right?
Yes,
I mean,
yes.
when I wrote that paper a decade earlier, I didn't know. I mean, I just used the solar system as an example. That's the only system where we found rocks until then. And I forecasted based on the number of stars per unit volume, how many rocks should be in interstellar space that may enter the solar system. And we concluded that Pan-STARRS will find nothing. Okay. And only the telescope that comes along in a year, called the Vera Rubin Observatory in Chile, will find. But then Pan-STARRS found one. And so that was intriguing to me. And of course, the astronomers called it a comet, because comets are just rocks covered with ice. When you have a rock very far from a star, it's often covered with ice, water ice, and the ice evaporates and creates a cometary tail when it comes close to the star, when it's warmed up by the starlight. But the only problem is, it's just like going to the zoo and seeing an animal and saying, okay, that must be a zebra, but then it doesn't have stripes. So this object didn't have a cometary tail. So immediately this title of a comet was taken out, okay, because it doesn't have a cometary tail. It doesn't look like a comet. And then it started being weirder and weirder. There were more and more anomalies about it as time went on. And, as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. So it meant that it has a very extreme shape. At the 90% confidence, most likely it was flat, pancake-like, and then it was pushed away from the sun by a mysterious force that declined inversely with distance squared, even though there was no cometary tail to propel it and no rocket effect. And I suggested that, it may be the sunlight that is pushing it as it reflects off it. For that, the object had to be very thin and sort of like a sail. And then I said, nature doesn't make such things, so maybe it's artificial in origin. Maybe it's a leaflet, something is written on it, and we should read the message. Of course, there was a huge pushback from the scientific astronomy community to that idea that it may be artificial.
Sorry, was or is continues to be?
Okay. I mean, my point is, here is something intriguing, doesn't look like a rock.
Yeah.
Let's look into it. Let's find the next one. And the point is that the mainstream said initially, there was a review paper written by experts saying it must be natural, period. And it was a bunch of, like a group of experts. And it reminded me of a book written in 1930, 100 scientists against Einstein's theory of relativity. And when Einstein was asked about it, he said, why do you need 100 authors? It's sufficient to have one that makes the point. That's all. All you need is to make a good point. So people come in groups, just like in the days of Galileo, because they feel more powerful. They enforce the dogma. Here's
the irony. Sorry, let me interrupt again, Avi. You said you get, and this is in another interview, you get better feedback from religious leaders than from secular scientists about your work.
That's true. Yeah, so my story was featured on the cover page of an Orthodox magazine in Brooklyn. And a colleague of mine at Harvard, Stephen Greenblatt, who studies Shakespeare, he wrote to me and said, it looks like the Orthodox community is more open-minded about your idea than your colleagues. Now, I should say that the mainstream, a few months after this review paper was written, where it was categorically announced that it must be natural, a team of people said, well, maybe it's a hydrogen iceberg, a chunk of frozen hydrogen. So when there is a cometary tail, but we can't see it because it's transparent. The problem with that is that such an object would not survive the journey in interstellar space. It would evaporate very quickly. So then another team said, well, maybe it's a dust bunny, a cloud of dust particles 100 times less dense than air that is pushed by reflecting sunlight. And the problem there is that it won't survive coming close to the sun and getting heated by hundreds of degrees. And so then a third group, and I mentioned this like group after group, after the conclusion was already derived by the herd, right? Why did these people have to write papers explaining the nature of this object if it was obvious to the experts that it was natural to start with? That's the question. And then the third group, and everyone immediately jumped on the third option, it must be a chip of solid nitrogen that was chipped off the surface of a planet like Pluto around another star. And the problem there is the mass budget. There is not enough solid nitrogen in the Milky Way galaxy to produce enough chips like that. But anyway, I make the analogy with New Horizons. Suppose, New Horizons is a mission we sent to Pluto, okay? And imagine it 1 billion years from now. And imagine it crashing on a crash course with a habitable planet like the Earth, okay? So the astronomers on that planet see this object, New Horizon, approaching them. They can't resolve it with their telescopes, just like we couldn't resolve it from the ground. And so they argue, what is it? And they see that it's being pushed by reflecting sunlight. By the way, there was another object seen by Pan-STARRS to exhibit that behavior. It was given the name 2020 SO. It was found to be a rocket booster from a launch in 1966. So we clearly can differentiate between an object that is hollow, like this rocket booster, pushed by sunlight, compared to a rock. That was demonstrated by the same telescope. So anyway, imagine these New Horizons approaching that planet, and the astronomers on that planet seeing it being pushed a little bit by reflecting sunlight and saying, well, it must be a hydrogen iceberg, a nitrogen iceberg, or a dust bunny. And in all of these cases, we don't need to do anything about it because these objects are so fragile that they would burn up in the atmosphere very early, up in the atmosphere, so they would never reach the ground. So the scientists say, that's it, case closed. And then the government still monitors, okay, this object as it gets into the atmosphere, because they want to figure out which of these three possibilities are right. And then they realize that it actually penetrates through the atmosphere and burns up only at the bottom of the atmosphere. And how is that possible? It must mean that it's very sturdy, made of materials that are very different than ices, exotic ices like hydrogen or nitrogen, and very different from a dust bunny that would have been disrupted on the first contact with the atmosphere. So the government publishes a letter saying, at the 99.999%, we can say that it's none of these three possibilities, that it's something of unusual composition, okay? And the scientists say, we don't believe the government because it didn't release the uncertainties in their measurements. And of course, the government is using the same satellites for national security purposes. They would never release the uncertainties. They just tell the scientists what they saw. And the scientists say, well, it will never be known. We don't believe the government. We will never know what this object was. Forget about it. Okay? And now you might think this is science fiction. Okay? And I should tell you, I don't like science fiction. I don't read books on science fiction. I don't enjoy watching movies on science fiction, except for one, maybe.
Yeah, I've heard you say you like science and you like fiction, but not together.
Exactly. Yeah. So everything I said is based on facts. And everything I said was related to the response of the astronomy community to Oumuamua. And actually, it turns out there was a meteor discovered in 2014 on January 8th, okay, that came from outside the solar system. And that was the first interstellar object, not Oumuamua. It's this meteor from 2014. And I wrote in 2019, I was invited for an interview, just like this one, with a radio station about another meteor. And I didn't know much about the meteors at the time, so I went to online and I found a catalog that the government releases of meteors that they happen to find through their set of sensors. That obviously they monitor the atmosphere for any objects that might be missiles, and so every now and then they see a meteor, and so they made up this catalog that is publicly available. And I asked my student, I said, look, Oumuamua was discovered in 2017. Let's check if this government catalog has any objects moving very fast, implying that they are not bound to the sun, that they came from outside the solar system. So my student, Amir Siraj, went to the fastest object and realized that it's the fastest just because it's a head-on collision with Earth. It was moving opposite to the Earth motion. So it was actually bound to the sun. But the second fastest ended up being from outside the solar system. It was moving at 60 kilometers per second relative to the solar system when it was far outside of it. So it clearly is interstellar. We submitted a scientific paper on it in March 2019 to the Astrophysical Journal Letters. And the referee, who is an expert, said, this paper should not be published because it's based on government-owned data, and we don't have access to that data, and we don't know the uncertainties in that data, okay? So as a result, the paper was never published, but just a few weeks ago, the government released a letter stating explicitly, that was the Department of Defense, the US Space Command, writing to NASA and saying, the paper by Amir Siraj and Abraham Loeb is correct in the assertion that this object came from outside the source, is interstellar, at the 99.999% confidence. And what do you think that my colleagues did? They said, this is not science. We don't believe the government.
Yeah, that's what I've been reading.
And so my story about New Horizons was not science fiction. It's based on facts. It's just happened to us. Now, what we have to do, what we plan to do, is an expedition to the ocean floor off the coast of Papua New Guinea, where this meteor landed. So it burned up in the atmosphere, but fragments from it landed in the ocean. And we plan to scoop them up and check. And the government did one more thing. In addition to releasing this letter, they released the light curve from the fireball, from the explosion of this meteor. So we analyzed it with my student a week ago, and we found that since this meteor burned up very low in the atmosphere, it actually was tougher than iron. The point is, there are two types of meteors. There are meteorites that are made of stone, of rock. Okay, they're called stony meteorites. They make up 95% of all meteorites. And then 1/20th of all meteorites are made of iron. Okay, so this object, based on the place where it started burning up, was tougher than iron meteorites by a factor of 2 in terms of its yield strength. I mean, this is just based on the stress that the atmosphere exerted on it until it started burning. Moreover, it's 20 times tougher than stony meteorites. So it's interesting. It's unusual, both in the sense that it was moving very fast outside the solar system, about twice as fast as stars move relative to the sun, in the vicinity of the sun. So it's very unusual in the high speed that it had outside the solar system. Unusual because only 5% of all stars move that fast. And it was also unusual in terms of its composition because it burned only at the bottom of the atmosphere. So I'm saying here is an anomaly. We have two objects that were the first ones to be discovered from outside the solar system. One is Oumuamua, size of a football field, found as a result of its reflection of sunlight. And the second, this meteor, 0.5 meter in size, about 200 times smaller than Oumuamua. It was found through the fireball that it created when it burned up in the atmosphere. So that's another way. You use the Earth as a fishing net to discover interstellar objects. And the advantage of that discovery is we can put our hands on the material that made this object. And we are planning to do that. It will cost 10,000 times less money than going to space. Instead of $1 billion in a rendezvous with an Oumuamua-like object in dating the next Oumuamua, here the cost is at the level of hundreds of thousands of dollars for an expedition that will last 1 week.
So
and
what's frustrating to me is that you are one voice and one of very few voices in public talking about this, and it's annoying to me that this is news. Like it shouldn't be. This should be something where everybody just
exactly
like children around some sea creature that washed up on shore that they've never seen before. They all crowd around, watch, they touch it. But instead, you're painting, not to repeat all the theme here, but you're painting a picture where there's 1 or 2 children left there actually discovering. Everybody else just goes and plays and then calls those kids names or ostracizes them.
But it's really worse. It's worse than that, I should say, because the public funds science.
Yes.
And the public cares deeply about this question.
Of course.
And the government cares about it. The government established a new office. President Biden signed into law a new office that will start operation next month at the beginning of June 2022. And this office is tasked with collecting all evidence about objects that we can't understand in the atmosphere. And I say, if the government and the public care so much about it, how can academia ridicule the subject, push back against the possibility that something unusual? Well,
there's fear because so I see this as as just a play of fear. You probably agree. You kind of you talk about this anyway when we talk about the echo chambers and tenureship and holding on to what's yours as an expert. But when I say fear, I mean on the philosophical front. When we look at stories like Galileo, but also stories around people like Giordano Bruno. And I know you've mentioned Giordano Bruno on the Joe Rogan podcast. Giordano Bruno is one of the, having grown up here in Canada and North America, we never learned of Giordano Bruno, but he is one of the most prolific philosophers, scientists of the 16th century who didn't start a cult, right? Wasn't a leader of anything. He was a roaming ex-monk who had ideas about how the universe might actually be, that he was heliocentric, that humanity wasn't at the center of existence. And he was involved in an inquisition for about 7 or 8 years, and only lived those 7, 8 years because he had deep political ties from an aristocracy who was learning from his science, because on the side he was making money as a mathematician and mnemonics. Yes, he was teaching mnemonics. But the church didn't want him speaking, and he was executed because of it. He was executed for his ideas.
Right. He also made some enemies and so forth. What it shows is that politics cannot be intertwined. It is part of our society, and but it should be separated from what we learn about nature. And unfortunately, it's intertwined with it. And there are many other examples. But let me argue against what you just said. I don't think it's just that, because, for example, you see the mainstream of science right now engaged in the study of dark matter, and it has been for half a century. Dark matter was first discovered by Fritz Zwicky, who again was an outlier back in 1933, when he argued that clusters of galaxies have more mass than you can see in stars. Okay, so there must be some invisible matter, dark matter. And at the time, nobody believed him. In the early 1970s, it was still ridiculed by the mainstream scientific community. But then in the 1980s, it started to become part of the mainstream. And since then,
as older scientists passed away and opened up the path.
The evidence became stronger and stronger. It was not just based on clusters of galaxies. There was evidence in galaxies, the way the stars move in galaxies, the way gas moves in galaxies, and then cosmology, the way structure started to form in the universe. It was basically, we wouldn't exist. Galaxies like the Milky Way would not exist if not for the dark matter. And the reason is simple. Ordinary matter is coupled to light, to electromagnetic radiation. And all the initial inhomogeneities, perturbations in the universe would have been erased, deleted, if there was no dark matter. However, the only reason that the universe kept memory of fluctuations or perturbations in matter is because the dark matter didn't couple to the light. And that led to the formation of galaxies like the Milky Way. Because on the scale of galaxies like the Milky Way, there wouldn't be any perturbations. Everything would be smooth. The Milky Way would never form if there was no dark matter. Just keep that in mind, that we all are existent. But the point
I will keep it in mind, but scientifically, I can't grasp onto anything that you've just said.
Anyway, I can elaborate, but
please don't.
But anyway, so it became popular, and then for about half a century, we've been searching. And the most recent, we've been searching in laboratories, we've been searching in the sky for the nature of dark matter. Which particle is it? It must be a particle that we're not familiar with. Our body is made of material that makes up only a sixth of the matter in the universe. So it's really embarrassing to get paid as a cosmologist and not know what we are talking about. We call it dark matter, so people think, oh, well, we know a lot. We don't know anything. We don't know what it is. So, and cosmologists are being paid for now of, almost a century to study the universe. They still don't know what most of the stuff is. That's embarrassing, And the Large Hadron Collider at CERN, one of its main goals, it cost about $10 billion. One of its main goals was maybe to produce the dark matter in the laboratory. And it was considered to be most likely to be the lightest supersymmetric particle, where supersymmetry is a theory that adds more particles to the ones we know. And then people said, well, it's in the natural range of parameters. The Large Hadron Collider will find it. It looked for it, didn't find it. We still are searching in the dark, okay? After $10 billion. So my point is, if we search for equipment from other civilizations for 40 years, and we invest billions of dollars in the search, and we find nothing, absolutely nothing, we would be at exactly the same point as the search for dark matter is right now. And you ask yourself, why is that not threatening to people? Why is that acceptable as part of the mainstream? Even though we know nothing about it, we put a lot of money. And there is always this, there are two quotes that are often mentioned. One from Enrico Fermi, another Italian, won the Nobel Prize, very important physicist. But he basically said, where is everybody? Like there are no extraterrestrials. So to me, it sounds just like sitting at home and not looking through the windows, okay? Because he didn't use a telescope to search for anything. He just said, where is everybody? Assuming they will come for lunch with him.
Sure.
Why would they do that? He's not that important in the cosmic, Albert Einstein was not the smartest scientist since the Big Bang. There was probably a smarter scientist on another planet near another star 1 billion years ago, okay? So the other thing is, the other statement that is often mentioned is extraordinary claims require extraordinary evidence. And this is a quote from Carl Sagan. People say, Carl Sagan said that, therefore, you're making an extraordinary claim. We don't have extraordinary evidence, forget about it. And I say something different. I say Carl Sagan was misleading in his statement because extraordinary evidence requires extraordinary funding. If you don't engage in the search, if you don't engage in the search, you will not find anything, like, okay, we see birds in the sky all the time without putting money into looking for birds. We see them. Obviously, that's part of our reality, okay? So we know what is part of our reality. Everything else requires investment of resources. So if there is any evidence that goes beyond the things that we see routinely, we have to put money into it. If we want to find the dark matter, we have to put billions of dollars into searching for it. If we want to find equipment in space from other civilizations, let's put billions of dollars before we say extraordinary claims require extraordinary. Like, how would we get the extraordinary evidence? So it's a circular argument. It's just like the philosophers refusing to look through Galileo's telescope, basically saying, we don't want to look through your telescope, and we don't want to build a telescope because that may actually, cost us money. And, until we have extraordinary evidence, we don't want to invest in searching for
may make their assumptions obsolete, right? There's fear.
Well, then there is the political issue of them indoctrinating society with the wrong ideas. And also, you look at the sky, you see the sun moving, and it's obvious to assume the sun is moving, right? Obviously, when you board the train and you see the ground moving, you realize that you're moving, the ground is not moving, but that didn't come to mind to people for thousands of years. They thought the sun is moving in the sky, therefore we are at the center.
You also said in another interview, and I don't remember the context, but I'd like for you to address it here if you want to or can. You said spirituality and the exploration of space are actually connected.
Right. Yeah. There is no business. I was at the Washington National Cathedral with Jeff Bezos, and he was arguing that, his long-term goal is to bring 1 trillion people to space and regard the Earth as a national park that you visit every now and then. And he views space tourism as a business plan. And he was inspired to go in that direction by watching Star Trek. And I basically disagreed with everything he said. First of all, I never liked science fiction. I told the person next to me, the director of national intelligence, Avril Haines, I said, I never liked science fiction. She said, we have to work on you. But then the other thing that I disagreed with him is there is no business plan to space exploration. Perhaps if you go very little above the Earth surface, if you go 1% of the Earth radius, as Jeff Bezos himself did, with going to quote unquote space, you may argue, well, maybe people will pay for that. I can make money out of it. But that's not very impressive. That's not really space exploration. The universe is 10 to the power 19 times bigger than the radius of the Earth. So if you go 1% of the Earth radius above the surface, that's nothing. You cannot show off in space. That's an oxymoron. And my point is, if you want to leave the solar system, there is no business. You can't make money out of this. It will only be a result of spirituality because we want to explore the unknown. You see, it's really the desire to know things that we don't know. What's above the horizon? And to me, that's the reason for our life. Just learning what's out there.
One of my last questions here: what does greatness mean to you?
Modesty, first, because it sounds paradoxical that in order to be great, you need to underappreciate yourself. And the reason is simple. There is something much greater out there. Okay, so it's not about us. We tend to think we came to the cosmic scene as main players, as the actors. And the first thing we find, we are not at the center of the stage. The second thing we find, the play started long before we arrived to the stage. The universe existed for 13.8 billion years. We just came at the end. How can we even imagine that the play is about us? Okay. And so my point is, let's find other actors. Perhaps they have a better idea about what the play is about. And our greatness would be in listening, in paying attention to whatever nature educates us about the bigger picture, because we are not a major component of the bigger picture. So greatness is recognizing your place. Even if you are an emperor or a king, or even if you are Putin trying to conquer a piece of land in Ukraine, you should realize that's just like an ant trying to hug a small grain of sand on the landscape of a huge beach. Okay. And if you see the bigger picture, you get modest. And then you also treat others better, because you realize that the differences among humans are really meaningless in the big scheme of things. And we better treat each other with respect as equal members of the human species, just because we are so insignificant, all of us. And let's just figure out what's out there. Why do we have, to put blinders on ourselves by construction? It's not as if you say, I don't have $10 billion. We do have 10 billion. We are looking for the dark matter. We are not looking for other neighbors in our cosmic neighborhood. And I say something has gone wrong in academia if we do that, because this should be like, there should be a department searching for extraterrestrials in every university.
So I'll end off with one last comment, and it's a comment based on another quote that you gave, and from a conversation that we recently had with Jill Bolt Taylor. She was a neuroanatomist that she had a famous TED Talk as well, and she's also an author. And her story was about seeing herself separate because when she was having a stroke. So her left and right brain were separating, and she was living two worlds at once. And the right hemisphere was enjoying exploring a new frontier that she didn't understand, but she couldn't communicate in the real world or in the physical world because her left brain was turned to mush. And so we talked about her experience there, and she said, and her and I both discussed how she was quote unquote trapped. She was seen as weak and as trapped, but she was in a place where she was exploring, but no one knew. No one could tell.
By the way, I don't care if anyone knows. So as far as I am concerned, suppose I get a high resolution image of an object, okay? Yeah. And it's beyond any doubt that it has screws and bolts, doesn't look like a hydrogen iceberg, doesn't look like a nitrogen iceberg, doesn't look like a dust bunny. And it has a label saying made on exoplanet Y, okay? So I know it's artificial. I don't need anything else. I don't need to convince people anywhere about it as long as I know the answer. And I would be happy with that. I don't need the second part of my brain to go and celebrate with people.
Well, so then you lay the groundwork well for what I wanted to read before. So it's again perfect. You say you can never tell in advance when you work on the frontier what is the right path forward. And I think one of the messages is we don't need to listen to people telling us what the right path forward is if we are on the frontier of exploring knowledge. And exactly. I think that's the main takeaway.
Exactly. And moreover, if you take a path that was never taken before, you have a chance of finding low-hanging fruit because nobody picked it up.
Wonderful. Wonderful. Avi, extremely educational. Thank you so much. You make me regret not studying science after high school, but I'm glad I have two, one high schooler and the other one's at First University. But well, I'm glad I have two sons that are actually going to be pushing me that way.
The only problem in pursuing science is very often the scientists that surround you.
We'll leave it at that. Avi, thank you so much for your time.
Thank you. Bye-bye.